Okay, that's good, that's good. Yes, so front end, exactly. We have front end. This is part of front end and back end, okay. So we can classify them to be standalone applications, let's say, right? Or transaction-based applications. What else? Full stack, okay, full stack. Okay, I think you were referring back to this one, right? This one, right? So here, yeah, in these rules, yes, we can classify them into developers of front end or back end or full stack to take care of the whole thing. If you remember also, here we were talking about these types. Standalone applications, interactive transaction-based, embedded batch processing, entertainment, systems for modeling, simulation, data collection, and system-to-system. We discussed all of them last time, right? And also we discussed two types of hosting, the web and the cloud-based. We said what is the difference between static dynamic and also these three different services introduced by cloud applications like software as a service, platform as a service, or infrastructure as a service. And we also had a quick discussion on artificial intelligence application, how they work, how they process information, how they reach a ground of info or let's say wisdom later on and so on. So in this part, we will focus on this title, software process. We'll look into different models that could be utilized. We'll look into the process activities, so what's included under each of these stages inside any model. We will look into changes, adaptation, and also modern approaches. Before I actually start talking about the program, the software process in general, I just want to ask you what comes to your mind when we say this word, software process?
Coding.
Coding, okay.
Outputs.
What?
Outputs.
I can't hear. Who's saying what?
Outputs.
Outputs, okay, nice.
The stage between input and output.
Stage between input and output. Yes. Graphical user interface. Well done. Okay.
Stage development.
Stages of development. Very good. I really like this. Let me ask you a very quick question. How many of you is driving? Hands up. Okay. Can you tell me how do you reach a destination in steps? So starting from the moment you enter your car all the way to the moment where you reach the destination. How is that working? Yeah.
You're going to turn on the car.
You turn on the car.
And you're going to start the Google Maps location
Okay.
period. And you're going to go.
Okay.
You're going to go by the Google Maps.
Nice.
And then till you reach your destination.
So do you work with any buttons?
Just the start.
Front. Just start. Okay. Okay. Then you reach the destination. What do?
You park the car.
You park the car.
You're going to turn off the phone.
Yes. You turn off the phone. Nice. And then you turn off the car. Exactly. And then you open the door. You exit. Very good. What you just explained right now is simply a process, right? So anything in life has a process part of it. When you cook, when you study, when you drive with a car, when you walk, when you practice, everything is a process. So the process is usually stages, as you mentioned. So how actually you can reach the final output? Like you said, we have inputs, we have processing phase, we have outputs, right? This is a process. So how is that working? Yeah? Now, I know we discussed this model briefly last time, but let's re-look into it again and what kind of changes apply here. So we talked about a specification phase, we talked about design phase, implementation phase, validation and testing. But then I can subdivide this still into requirements, specification, design, sub-design, like subsystem design, implementation, subsystem test, system integration, system verification. That's not the issue. Look at this. This is entirely part of specification, right? So I can see that system design, for example, is common stage between specify and design. It's a transition point, right? So there should be good communication at this stage, heavily enough, to make sure that there's no miscommunication at any point. Same for implementation. You will see it common between design and implement, right? Between testing and implementation, the stages of subsystem or integration, testing, it's all part of the process. It's common, right? So this can tell us how powerful and interlinked these stages are to each other. We can't treat them entirely as standalone stage, right? They hold some information that will be common and some others that will be separate enough. So how would we actually describe the process? We describe it in terms of the output, as you mentioned, right? So output is simply the final product we're talking about. What is the software you're handling to the stakeholder at the very end? You're also discussing the rules and responsibilities. So I'm a team of 4 people. Okay, how will we work together to deliver this product? Who's going to be the designer? Who's going to be the person responsible for collecting requirements? Who's going to be the person implementing? Who's going to be the person who's testing, right? So we discussed the current resources, their own rules, their own responsibilities, and also a very important thing we call pre and post conditions. So I asked actually the guys in the first section, and they seemed to not be aware of this concept, so let me just jump in and explain something to you. Okay. Can you all see the screen? Yeah? Okay. So there is something we know as use case diagram. We look into it mostly in the design phase. Okay? How it works. We look into this box as a system boundary. Okay? What's a system boundary? What happens inside the system scope? So what kind of features the system supports? What kind of communication happens or takes place, right? And who are the people involved into that process? Let's assume we're talking here about Moodle system. And let's define 2 basic rules. Can you give it a guess? Huh. Choose any 2 rules.
User must be an advanced faculty
Faculty or student. Perfect. So I will represent this here as an actor. Okay? That's an actor. I will call it student. And another actor that I will call faculty. So now I'm saying these 2 actors have access to my system. Okay? Then I will say, okay, for faculty, what do we do on the system? For example, I can add submission, right? I can grade a file. Yes, I can even log in. Yeah? Agree?
Yes.
And of course, many more. But these are some use cases. All right. Do the students share any of these use cases? Login. Nice. Very good. What is unique to the student that I'm not having access to as faculty?
To able to submit.
Submit a file. Very good. Huh. View the grade. Right? And many more. Right? So this is, again, a very simple visualization, but it can tell you who are involved, yeah, what they do, how they do it. So sometimes you will see that one task depends on another task. Like, for example, you can't log in without signing up or having an account registered, and so on. You will see this later in the SE201 course, but for now, this is just it. So if I talk here about login as a use case, so let me just say, okay, I'm working now with the login use case. Can you specify some preconditions? Having an account. What else?
To be a student in the Faisal.
To be a student or faculty, doesn't matter. To have a rule,
Yeah.
right? So to be registered in general on that platform. Very good. What else? So that's a very good point. We don't have access, let's say, to Gmail accounts. It has to be atalfaisal.edu.
Yeah.
Very good. Anything else? Let's assume this is it for now, okay? Can you tell me any post condition? So what happens when you log in?
It has to authority to like more
Authentication.
authentication.
Excellent. Very good. So we have post condition. So now it goes into authentication. A double check with the server and the backend database, as we explained before, right? And it will be able to tell whether your credentials are accurate or not. So there are one of two possibilities, right? Either all's good, and in that case you are redirected to the dashboard. You can resume whatever transactions. The second case is it's not working, and in that case you have to retry, right? So in that simple format, we just looked into a single use case, one feature in our program. We were able to tell what happens before, what happens after, right? Now, do you think this is just theory-based? Is it only theory? No. Each of these conditions will require design and coding, right? How would you verify this is right credential? This is coding, right? How would it double check with the back-end server? Coding, right? How would it make sure that this domain is valid? Coding, right? So again, this is entirely one cycle. So making sure we are on the right track of choosing the right process, big part of it is knowing these pre and post conditions that we use before any activity, right? So if we think of it like a stage-based level, I can say, okay, are the users satisfied? Am I taking the right requirements? Am I good to go? Right? These are all things that will decide whether or not this process is successful. So now let's classify these models. We have, of course, more than these two models, but we will just introduce this topic briefly. So in general, there is something we know as plan-driven approach. What's a plan-driven approach? So software as a lifestyle doesn't work so haphazard. Like we can't really say, we want to build a software, let's build it. It's not that, right? It's very structured. And it's based on, what is that?
Motivation.
A motivation, of course, and a plan, right?
Yeah.
We need to have a plan, a good plan. Having a good plan ensures that at a very critical stage of your project is not falling apart, right? It's still functional, you're still able to deliver. That's the main point here. So plan-driven model. Mostly, this is the entire process for waterfall model. I'll discuss this in a while. Then we move into incremental models. And this is plan-driven and also agile-based. Have you heard of agile before? Okay, this is a very interesting concept. You might have heard of Scrum, if any. No?
Yes.
You did. Okay. No? Okay, so there's something we call Scrum and Agile. I'll discuss them briefly as well. But in general, this is very innovative. Like, this is the trendy approach. Okay? We'll talk about this. And of course, there is the reuse-oriented model. How many... Okay, let's assume I'm building my Moodle. We discussed previously like how to customize and how to build or use, let's say, a general application. So among all applications that you use, let's assume you use 10, 20 applications every day. How many of them you think they're built from scratch? And how many of them you think they are built on top of other applications or other APIs or other even components? Like, you don't build everything from scratch.
Most, if not all, are based on it.
Yes.
Thank you. So that's why you will see that data are interchanged currently between multiple applications. There's something we call it centralized design or architecture, which is similar to the blockchain as an idea, where you can develop something that would be, let's say, it sends messages back and forth to different other applications, and it can get you whatever outputs, let's say, that you aim for. But in general, let's compare these three for now. So here we have separate and distinct phases of specifications and development. Let's get back here. Remember when we said some of these are actually common between big phases? It's the same idea here. So here we're saying specs and development will be completely two different phases. They don't overlap at any point. With the incremental, we say that specification, development, and validation are interleaved. With the reuse, we can say that you assemble a system from existing components. Okay, let's compare first when to use each, then we will start taking some examples. Okay. So here, remember when we said there is a very important concept when it comes to building a software? We brief them in these three mnemonics. We call them STC, or scope, time, and cost. So cost can be any possible resource, not necessarily cost as money, right? It could be resources like manpower, right? It could be hardware devices, could be licenses, could be anything, resources that are available. So when do we decide if we go for waterfall model or the plan-oriented or driven model, or the iterative or incremental? They're both the same. Yeah, so these two names are used interchangeably. So again, we look into scope, resources, and time, then double check. Are they fixed? So I have fixed requirements from day one, all the way to the end of the program. If I have clear scope, fixed, it's not changing. If my team is constant, so you have 10 people in your team, and these 10 people would assume they work with you till the end of the project. Time, like I'm having 5 months duration, and it's 5 months. Okay? So if everything is fixed, which one you think we follow? The waterfall. Okay? The traditional approach. If they vary, and by vary here we mean there are lots of variations and changes. Okay? So like when I come to you saying, okay, I'm the stakeholder, and I ask you to build a software, I tell you, okay, I want a car, let's say that, I don't know, I can drive it, let's say, on high-speed roads. Just anything. I can use it, let's say, for racing. This is my requirement, okay? Then after a month, I came to you, okay, no, there is a new requirement. I want my car to be able to swim, if possible, okay? And after another month, I want my car to fly. That's a new requirement, right? And every time you make a change, this can take the scope of the project somewhere else. So when you design something to drive, it's different from how it goes, let's say, swim, or how to fly, right? So in general, if these requirements keep on changing frequently, then you will need to go with iterative model. So you can satisfy the customer. So this model is more like customer-oriented approach. This one is product-oriented approach. What is the difference? So the priority in the first one is to have a product, regardless. It satisfies you or not, there is a product, right? This one prioritizes the user, the customer, exactly. So is that what you want? If yes, fine. If not, we repeat. That's why we call it incremental. Okay, so waterfall from the flow, this is linear. So we go step by step. It's rigid and hard to change, okay? Feedback is collected after completion. So I brought you this car, okay, and I told you, okay, is that the one that you want? And I told you no, I want it to swim, right? So this one is not taken immediately. You keep it to the last stage when the product is ready. And of course, the delivery here is one piece, right? So I give you the car as one piece. I don't give you the wheels first and then the engine, no, okay? So this is best, sorry. Okay, here we go. Okay, so this is best for the well-defined scope, stable requirements, okay? And again, think of all the three. They are fixed, they are stable. On the other side, I have iterative. They work with the repetition. They're cyclical, so they can repeat in lots of iterations in an incremental way. They are flexible. You can easily adjust and change at any point of time. And here, feedback is taken early after each cycle. Okay? So I designed the engine, I brought it to you. Is that working fine for you? I designed the wheels, I showed them to you. Is that what you aim for? Right? That's the body, that's going to be the color. So I customize each and every component based on the feedback I receive at every stage. Multiple evolving versions. So I don't give you the whole car at once. No. I give you the components one by one, okay? So I can subdivide the features or functionalities into releases. But again, I'm not giving you wheels separate. I'm not giving you the screen separate. Not this. I give you a version of a car that would be very basic, okay? Okay, that's one. The second would be, let's say, something that's more fancy, okay? Then the third copy might be the one that you aim for, and so on. So I just show you how changes are delivered and how it could actually affect the progression of the entire product. So the final version, that's what I wanted to deliver to you. The final version here is not just a single component. It's a full software, but it's not yet complete. Now this is best for projects that are having evolving changes, having very unclear scope or requirements. So, okay, just before I show you this, let us try to explain this in practice. So let's talk about the general phases. I have requirements, then design, again then development, then testing. Now let's think of it as waterfall model. So I'm here now, and the customer gave me requirement 1, 2, and 3. Okay, I move to the design phase, then development, then testing. I'm done. I don't get back to the user at any point. So only this phase had the involvement. Then when would you meet them again? After you test. What do you get? Yeah. There is a release, right? So you end up with a single copy of a product. Now once this is ready, what goes here? Feedback, exactly. So now I get back to the customer and I ask for feedback. One of two possibilities.
Positive or negative?
Customers?
It could be a positive one or
A positive or negative? Positive, what do? You deliver, you're done. Yeah? Negative. You go back to requirements. Okay? So that's the waterfall model. If the customer is not happy, you have to repeat. So if I'm just submitting by the due date, what's the risk? I'm here. I'm here. This is my submission and this is the due date. 2 or 3 days.
Never have time to fix it on.
There is a risk. Right? So there is a risk that you might end up with a scope breach. You cross, let's say, a milestone, or let's say you exceed time, whatever resources you have, right? This might already cost you, yes?
If you're at the risk of repeating everything from the very start, then why would you go with this approach instead of asking for it?
Again, can you
If you're at the risk of repeating from everything from the start,
Hmm.
why would you go with this approach instead of asking?
Okay, so again, not all the projects are requiring lots of lots of changes and scope needs. So sometimes I'm very clear. I tell you, okay, I need a basic calculator. Okay, I need this calculator to accept user inputs, to be able, let's say, to do I don't know, plus minus division, multiplication, just these basic things, and possibly some additional, let's say, mathematical transactions. I can be very specific to you. I can tell you I need the power, I need, let's say, the square root. I can tell you, right? So now I'm not talking about requirements that are exponentially changing, right? This is something that's very basic, right? So functionality-wise, here we're not talking about design, by the way. We're not saying that this is appealing or not, yeah? So there is something later you will take as user experience design, UX design, or user interface design. This is another story. So here I'm talking about the functionalities, like how the application actually works. Is it satisfying my needs? Let's say I'm working in a factory and I do a specific task manually every day. Is this system now that you're proposing replacing my need to do it manual? Is it going to save me time? It could do the job, right? But it can do it in 10 minutes while I do it manually in 3 minutes. Makes no sense, right? So here we're talking about functional, non-functional requirements. In terms of speed, in terms of performance, in terms of security, in terms of quality, how many users can accommodate at a time, and so on, right? So this is waterfall. Now how would this change if we're talking about incremental? Now let's assume this is incremental. And again, I do start here from requirements, design, development, and testing. All right. I start here again, right? I say I have requirements 1, 2, and 3. Okay? I document. Then,
I check.
what?
I check if I have the correct requirement.
Excellent. So I get feedback at this stage. Now the customer says what? Again, one of two things. You're good to go? Or, no, I request requirement 4 and requirement 5 to be added as well. And in that case, what do? You reiterate on requirements. Now you add to it requirement 4, requirement 5, double check again. Is that what you want? Yes, you're good to go. Okay? So only when I get the approval from the stakeholder, I'm ready to move to the second phase. So now I know all the requirements, now let's design. Okay? So I come up with any prototype, I don't know. I have all the diagrams, all possible design related work. Then again, I stop and I check. So again, could be easy to go or simply requiring some enhancements, right? Again, we do the same for development and also for testing. Yes, Liam?
Now, if you are at, for example, developing stage, and then the user, maybe the customer, will vote of another requirement, can you go back?
Okay. So in that case, again, keep in mind something. Like we agree on the entire. We agree here on the entire scope of these requirements, right? But we do deliver them how? As increments, right? So So I might, in the first cycle, I might only work on one feature, which is, let's say, R1. So when I'm done with the first iteration, showing you the first deliverable, which is R1 completed, okay, in my second iteration, I can get back and add a new requirement. That's why we say changes are always accepted in this model. You can't say no to the customer, whatever you want, right? So we finish, as we said, so this could be, let's say, for R1, you finish design R1, you test R1, you deliver R1, right? And of course, after every stage, we do a stop for feedback. So now we have R1. We do the same for R2, and so on. So changes could be incorporated at any point. What is the risk? Like, you're happy as a customer, right? How about development?
It will take time.
Taking time. So we said this works best when you don't really have a very strict timetable, right? You can actually flexibly
If you
change.
have a budget, it might exceed the budget.
Thank you. So we're talking about time, cost. Resources are also stretched. So you might need more people to complete the work assigned, right? And also, you might fall into scope breach. You heard of scope breach before? So like, we agreed at first to deliver, I don't know, a car that drives, right? But we ended up with a car that flies. So like, you keep on saying yes, 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 but at the very end, you get far away from what's meant to be. Yes, please.
But isn't that the same for incremental processes as well, where it's kind of like expected that the final product differs so much from the original initiated plan?
You're talking about incremental?
Yeah, like
These are incremental.
I know this is waterfall.
No,
But
no, this is incremental.
this is incremental.
This is incremental.
Oh, sorry.
This was the waterfall.
Okay, yeah.
They're similar, but again,
No,
the
no, no,
feedback is the. Do you figure it out?
Yeah.
Okay. Make sense? Yes, please.
For the scope breach, is it for the customer or for the developer?
Both. I mean, for the customer, they're always satisfied. They won't say no. But they can overcomplicate things. So later on, they can come to you saying, this application is very complex. I don't know how to use it. It has lots of features. I can't find what I want. Right? So sometimes when you are very, very flexible, this gets to make it a bottleneck. Okay? So it might be the same issue they request. Yes, please.
Doctor, I think the best plan is to use both. Like, I'll be clear from the beginning. If I move to the next step, I will not go back. But I'll show them the result after each step. But I will tell them from the beginning that
That's a very good thing.
yeah. That's
You
the
will
best.
see, inshallah, when you move to the project management course, I think 4th year. There is something we call it charter. Remember when we talked about planning phase?
Yeah.
So after we plan, we come up with a document that's called charter. Has everything that we can possibly agree on in all our previous meetings. So we sat together, let's say for 10 meetings, we came up with that set of requirements, and we're all good to go. I put all of these in one list, and I asked the customer to sign on it.
Yeah.
Why is that? Because you want to stick to a timeline, you want to stick to a budget. You don't want to say like, okay, I was telling you this, and you did not do it. No, it's written, it's listed, and if we did not deliver, then it's our fault. So charter gets to be a contract in between both entities.
Yeah, that's the best solution.
And of course, yes, what you're saying is excellent actually. So as you move, based on your own experience as a developer, especially with the team that you're working on as well, so you get to build an entire experience that could be applicable to more than one project. It might not work for some others, right? So every project is a new case, and every case requires some experience inputs. Great. So that's briefly what this waterfall model is telling you. We go for analysis, design, implementation, testing, maintenance, all in one row, right? If you request any change, you need to go back and start from the beginning. So it has its own drawbacks, of course, like we can't accommodate changes. And again, some of these changes could be relevant still to the scope. But they might, let's say, show up later on after this agreement was made. A phase should be complete before moving on to the next one. And it's used mostly in large projects where the system is developed in several sites. It has clear documentations, well-defined phases, formal approvals to reduce miscommunications and meet needs. I just want to stop it here at this point. So clear documentations, what do we mean by this? So again, later, like in the web course, you will take a language called React. You might have heard of it. React Native.
Yeah.
React Native is working with the iterative approach. Okay. So it is mostly something that would never say no to a change, but it has the worst ever feature a developer can have. You can't keep track of these changes documentation-wise. So when you go back, let's say after 3-4 months, and I'm not talking about long duration, you will see that many changes happened and none of them were documented. So if the team was replaced later on, or if there was no proper handover, let's say from one team to another, you lose track. You can't really tell what's happening.
Is there
Very
no
hard to
supplementary
change.
software to accommodate this? I'm saying, is there no supplementary software to accommodate this?
There are lots of management tools that can
Yeah.
possibly do some work relevant, but security is always a factor.
Oh,
So many organizations will not go through such solutions. They will feel like it's a big risk to them.
If I have a question,
Please.
what is wrong with the software? Is it that the syntax is changing, the language is evolving? What do you mean by changes that are not documented?
Okay, so you might find a lot of code pieces, for example, that you don't know why they are built, right? You can't really tell. This wasn't part of the agreed on requirements, right? But because you kept saying yes to changes, you can no longer trace it back. You can't say why this piece of code is there. What happens if I delete this piece of code, right? So lack of documentation in general is the worst thing a developer can fall in. Just go back to any previous code that you made last year, just last year. Try reading it.
yesterday.
You will feel like it's different. Like you will say, who did this? Why did I do that? Right? Sometimes even you have documentation, like you code things and write comments, but still you feel like it's someone else who made it. So documentation is quite an important factor. Yes, please.
What happens at that point? Like, can you continue the project or?
With waterfall, you have clear documentations. So you have the process well documented, which is not the case with incremental. What happens when I face like there is no proper documentation? If the team is stable, if all resources are still existing, they will just continue. Okay, if something went wrong, like the team quit, the resources fail, the hardware changed, right? You might require more expert people to join and start from the scratch. So they will come, they will learn, they will keep things, they will remove things. You might request a whole new software. Yeah, that's the case, right? So the cost, just because of documentation, might be very huge. So iterative in general, they have low cost because again, you can embed changes as you move. But again, it's easier to get feedback on every phase, more rapid delivery as we mentioned. Like every week you can imagine having one deliverable, right? So it's very fast when it comes to seeing results. But again, drawbacks are you can't have full visibility on the process. There's no documentation. The progress can only be measured by deliverables, but you can't really see it properly documented or measured in any other way. And the structure, of course, can suffer, as we explained, can degrade with every new increment that you are adding. So you get things more complex, harder to change later on. I will stop it here. So next time we will discuss the measures of how can we choose like a process based on what, and we will also discuss few case studies. So you will see a case study for a system, and you will be able to tell which of these processes would be the best. Do you have any question on what we discussed today, please?
Can you say that waterfall model is more formal?
Is more
Formal.
formal? Yeah, of course. More formal. Okay. Any other question, please?
If I am like أنا البروجرامر واشتغلت بالووتر فول هيندفع لي أكثر صح من إذا اشتغلت بالثاني. مو الووتر فول الانكريمنتال قصدي، إذا أنا عم بشتغل بالانكريمنتال هيندفع لي أكثر من لما أشتغل
Of course. By the way, most of the project managers you will see in my positions, they work with the agile techniques, especially with the critical systems. You can't really start huge system, let's say for banking or let's say for airports. You can't actually work with these big systems in waterfall because they request lots of changes, right? So of course the cost is completely different and it's way higher. Yes, please. Can the QR